Hello again. So this is part 2 of section 1.5, talking about uncertainty. We just wrapped up doing types of error, random and systematic error. Next is significant figures. So again, this is part 2 of section 1.5. Significant figures are interesting. Like, we didn't teach them last year in general chemistry, but you do need to be aware of them for AP Chem. So if you're having trouble with it, it'll be something we practice all year, but this is something you need to be familiar with for the AP test. The term significant figures refers to all of the digits of a measured quantity. And let me move my face kind of down here. Hopefully that'll help. Okay. When rounding calculated numbers, we pay attention to significant figures so we do not overstate the accuracy of our answer. Now, the more digits we have, the more certain our measurement is. Back when we were looking at measuring the length of the pencil, we had 25.7 centimeters, but we couldn't estimate it beyond that 0.7. That would have been a significant figure. Okay, counting significant figures is going to come first. So there are a couple rules we need to follow when we count significant figures. First rule is that any non-zero digit is going to be significant. So for example, anything 1 through 9 is a non-zero digit. Those are all significant. So if we look at this number, 354, or my mouse, 354, we've got 3 digits. None of them are zeros, so this number has 3 significant digits. This number here, 44,323, these are all non-zero, so 1, 2, 3, 4, 5, 5 digits, they're all significant. And then over here, again, if my mouse wigs out or doesn't seem to be pointing at the thing that I should be pointing at, it's probably because it disappeared on me. Here, I've got a 1, I've got a 2, 12. Those are 2 significant digits. Second rule, zeros between 2 significant figures are themselves significant. We call these sandwich zeros. So if you think of like these non-zero digits being the bread, and then the zeros are the cheese and the meat in between, they are significant. So here we've got a 3, which is significant, so there's 1. We've got this 3 here, which is a second digit, and we've got this 5 here, which is our third significant digit. Now, these zeros are sandwiched between them, so we count those as being significant as well. So 0, 0, we've got 5 significant digits. That's for sandwich zeros. If we have zeros at the beginning of a number, they're never significant. These are place-holding zeros. For example, if you've got a number less than 1, you've got this 0 here, this 0 here. Those are holding the place to say that this is in the, let's see, tens, thousands, or tens, hundredths, 1,000ths place. No, sorry. It's probably the ones, tenths, and the hundredths place. So this 2, okay, this 2 comes in the hundredths place. Now, at the beginning, they're not significant. If we were to count the significant digits in this number, we'd have the 2, the second 2, the sandwiched 0, and then the 3. So this should be 4 significant digits. Zeros at the end of a number are significant if a decimal point is written in the number. Okay. Here we go. And we're going to recap some rules. So these beginning zeros do not count. But we've got this little decimal right here. So if we're counting significant figures for this first number, we've got the 3, we've got the 4, we've got the 3, we've got the 2, and then zeros at the end if a decimal point. So we've got the 2 zeros that are significant. So we've got 6, there we go, 6 significant figures. Here, we've got 800, but we don't have a decimal. So only the 8 counts. So we only have one significant figure in 800. Now, if we look at, let me move my face, you can see it. If we look at this number, the 8,320, see this little decimal point right here? We've got a decimal, so it's at the end of the number, meaning that this 0 is significant. So we have 1, 2, 3, 4 significant digits. Now, we didn't have a decimal here. We do here. So sometimes AP will put a decimal at the end of a couple zeros to indicate that those are significant values. One way that will help you remember this is to keep it on the down low, or like keep it on the DL. I know that was popular a couple years ago, but here's kind of a trick to remember it. So down low has a D and an L in it. So if your decimal is present, start on the left. That's where we get the D and that's where we get the L. Vice versa, if your decimal is absent, you start on the right. You don't start counting until you reach a non-zero digit, so again 1 through 9. And then once you've started counting, you can't stop until you reach the end. So let's see how this little shortcut will help us remember the rules. So in this first example, we do have a decimal. So decimal is present, we're going to start counting on the left side. Don't start counting until you reach a non-zero digit. Okay, so we've got all these digits in front of here, all these zeros, but we can't count those until we reach this 9. So we've got the 9, we've got the 8, where'd my mouse go? The 9, the 8, we've got our sandwich 0, we've got our 3, and then we can't stop counting until we reach the end. So then we do have to count both of those last zeros. So we now have 6 significant figures in this number here. Okay, let's do the same thing for this number. So keep it on the down low, the DL. Do we have a decimal? Oh, nope. Oh, looks like my comma's in the wrong spot. Sorry, a little typo there. But no, we don't have a decimal. So we're going to start on the right side. Okay, don't start counting until you reach a non-zero digit. Okay, so all of these zeros here, we don't count because we're starting from the right side. So our 3 is going to be our first one, then the 8, then the 0, then the 5, and then the 7. So we have 5 significant digits in this number. Had a little technical difficulty there, but let's get back to this. I need to readjust my screen, sorry. Okay, significant figures in calculations. So we just got done counting significant figures. We can use them in calculations. We've got 2 different types of calculations. Addition or subtraction follow the same rules, and then multiplication and division are going to follow the same rules. So for addition or subtraction, your answer is rounded to the least significant decimal place. Here's an example. Solve for the following. So if we have these 3 numbers and we're trying to add them together, we need the least significant decimal place. So one thing I like to do, and it really does help, is to line up all your numbers vertically and lining up those decimals. So if I've got 20.42, I've got 2 decimal places there. I'm going to line up my 1.322. So notice how my decimal points are in alignment vertically. Got 3 decimal places, so 3 numbers after the decimal place is what that's referring to. And if I add my third number in, 83.1, again, I've got my decimal place all lined up in a row. I have 1 digit after my decimal place here. If, notice that I left these blank, and if I was to add up all of these numbers as is, I get 104.842. Now, our rule for rounding our answer is to go to the least significant decimal place. So since we only have 1, like 1 is our least significant, that's where we're going to round in this instance. So only 1 decimal place in this instance. What I like to do is I like to draw a line right down here. So that's kind of my cutoff point is what I call it. It goes right after this last significant digit, since that's one we're looking for, and then I can compare where in my answer that comes off. I like the line. You can do it by just counting the decimals like we did up here as well. So if we're to round this answer to the correct number of significant figures, it would be 104.8. Again, remember that you have to have your unit on all of your measurements. On the AP test, you will be docked points, as well as in my class, you'll be docked points if you don't have your unit. That is for addition and subtraction. Same rules would apply if these were being subtracted together. For multiplication and division, let me try to move my face down. I hope it's moving my face, because in the pre-recording it doesn't, okay? Multiplication or division, your answer is rounded to the number of significant digits that corresponds to the least number of sig figs in any of the numbers used in the calculation. Okay, weird English. I hope it'll make more sense when I explain it. So here's our example. We've got 6.221 times 5.2. Okay, for multiplication and division, we can just plug that into our calculator. We don't need to do anything fancy with the decimals. So if we plug that in our calculator, we'll get 32.3492 centimeters squared. Okay, if I want to round this answer to the correct number of significant figures, then I have to know how many sig figs I have in each of these numbers. So if I look at my 6.221, there's non-zero digits, so there's 4 sig figs. If I go to my 5.2, those are all non-zero, so that should be 2 sig figs. If I'm comparing my 4 versus my 2, 2 is the least significant. It's the least number, so that means I have to round my answer to that least number. So round the answer to the same number of sig figs. Let me try to move that again. Round to the same number of sig figs as the measurement with the fewest sig figs. So in this case, we would round to 2 significant figures. 32 would be our answer. And again, we do need that unit. We're going to be talking about rounding here in a moment. I think it's the next slide, actually. Okay, so some other things to keep in mind. Exact numbers are assumed to have infinite significant figures. So again, exact numbers, the very first thing we talked about, those are the definitions as well as the counting numbers. So if we have the definition that 12 inches is equal to 1 foot, when we're using that in a calculation, we don't use any of these to round for significant digits. So even though there's 2 sig figs here and 1 sig fig here, we don't go by that when we're rounding significant digits. We only go by the measurements in order to round for sig figs. The rounding rules, so look at the leftmost digit to be removed. If it's less than 5, there's no change. It's pretty standard rounding rules. So for example, if we've got the 7.248, we want to round this to 2 significant figures. We want to keep the 7, we want to keep the 2. So we're going to look at this 4, because that's the leftmost digit to be removed. It is less than 5, which means that we are going to keep it as is. So when we round this, we keep the 7.2, and we don't round this 2 to a 3, because that 4 is less than 5. If that digit to be removed is 5 or greater, then we're going to round that up by 1. So, for example, if we have 4.735, rounded to 3 significant digits, okay, so the 4 we're going to keep, the 7 we're going to keep, the 3 we're going to keep. We're looking at this 5 here. That's our that's our leftmost digit to be removed. That's going to round this 3 up to 4.74. Similar here, 2.376, 2 sig figs, we're going to keep the 2, we're going to keep the 3. That 7 is greater than 5, so we're going to round that 3 up to 4. Standard rounding rules. And then our last step is if we're calculating in a multiple step process, for example, when we get into dimensional analysis or the fence posts or the railroad tracks or factor labeled method, whatever you know the name by, when we get into multiple steps, you want to keep all of your digits or a couple of the digits throughout those calculations, and then you round at the very end. That's all I have. Hope that was helpful. See you next time.